Hi, I'm Carl from the Internet of Bugs. I've been making a living from writing software for 35 plus years now, and I'm trying to do my part to make the internet a less buggy place. So today's books are The World of StarTrek by David Gerrold and Programming Language Pragmatics by Scott. In February of 1967, a Star Trek episode first aired. That episode was called Court Martial, and it was the source of confusion for me for most of my life until very recently. Spoilers for a 58-year-old Star Trek episode, by the way. Don't say I didn't warn you. The episode kind of is a whodunit mystery. The breakthrough that the characters have to figure out the mystery revolves around the way that the computer works on the show. In the episode, Mr. Spock discovers that there's an error in the central computer's chess program. And because of that, he concludes that the computer's memory has been tampered with. In this case, someone has altered the ship's log, effectively replacing a section of surveillance video with a fake. When I was a kid, I loved computers, reading sci-fi books, including Star Trek, and also watching and rewatching a lot of Star Trek reruns, because we only had 3 TV channels back then, and we didn't have internet, and TikTok wouldn't be invented for decades, and okay, I'm old, just leave me alone. Anyway, this episode confused me as a teenager because it did not make any sense with respect to what I knew about how computers worked. Computers had chess programs, and computers had logs, and there was no world I understood in which forging a log over here would affect the chess program over there. As I got older and I learned about how TV shows were written, I decided that it must just be that the people that worked on the episode had no clue how computers worked, so they just wrote the wrong thing. As I got even older and I understood the timeline of how computers were developed, I realized that a lot of the things that I knew to be true about how computers work wouldn't necessarily have been true in the mid-1960s, because a lot had changed in the decade since that episode was written. And then, as I got even older, much older, things came full circle. And here in the mid-2020s, that episode finally makes sense. In fact, it seems almost prophetic. Let me explain. There have been a lot of advances in programming for the last 60-ish years. First off, there are a number of formerly common programming techniques that these days are considered harmful, like goto and global variables. And in order to avoid those harmful things and write better and safer programs, we've had lots of advances in the science and the art of programming, and better programming languages and tools. Let me give you a simplified case for 3 of the biggest, most important ones. One is variable scope, when a variable can only affect things within a certain area. 2 is types, more than memory types, but like a name can't be assigned to an address, even though they're both strings. And the 3rd is error and exception handling and checking. So think about it. Basic and assembly are really simple with a flat variable address space, not a lot of structure, basically no way of handling error built in. With Pascal C, we got functions, return values, some sample types, some simple types, some simple local variables. C++, Java, Objective-C gave us objects where we could have variables private to instances. Public and private methods defined types. For example, if you accidentally confused an integer zip code with an integer phone number, you could get a compiler error if you tried to pass one to a function expecting the other one. Swift and Kotlin gave us optional or nullable types that cut down on a whole class of errors. Go gave us conventions for error values getting returned alongside functions as result variables. But the algorithms that in the heart of LLMs and neural nets in general don't use these new advances. It's conceivable that going and manually changing some chatbot's weights to get it to misreport some past event might end up affecting how well the chatbot plays chess. And according to some of the Gotham chess videos I've seen, they definitely don't need anything making chess harder for them. I'll put a link to a couple of those videos below if you're curious. They're pretty hilarious. An LLM has potentially trillions of parameters, which are effectively just global variables, all with the same scope, all with the same type. We have no way of understanding how changing any of them might impact any others, not to mention how. And there's no inherent or internal error handling in the system. Welcome back to the 1960s. And this matters. Like I said in my companion video on my main channel, LLMs are just software, and they are subject to all the rules and disadvantages of software. And software gets complicated, and the bigger the software project, the more complicated it gets. Think about it. Imagine you have 100,000 lines of code and hundreds of global variables with goto statements everywhere, and you need to make a change. You need to do 2 things. First, you need to make the change you were asked to make, add the feature, fix the bug, whatever. Second, you need to avoid causing any other changes, breakage, side effects, anything else in the project. That first part is relatively straightforward. The second part isn't. The larger the project gets, the more potential interactions the rest of the project has with the part that you're changing, and the more difficult it is to make sure you don't cause any new problems. How many different things do you need to check to make sure you didn't break anything? Well, with 100 or so global variables, you need to check 100 or so. And what's worse, assuming you do a perfect job with this task, and that's a big assumption, then you just added one more thing you need to check. So when you need to add your next change, you need to verify 100 or so plus 1. And the one after that, 100 or so plus 2. And the longer you work on this project, the harder you make things for yourself. I've lived through this before, and it was a nightmare. I did a couple of projects in the early 1990s for a now-defunct retailer whose point-of-sale system had been written internally using a version of the BASIC programming language with ISAM database extensions. And it was more than 100,000 lines of BASIC code, complete with line numbers and go-to statements everywhere. Changing anything was incredibly risky and took forever. Now, I can't prove the system contributed to the company's inability to adapt to online sales, causing them to fail when the internet took off, but I wouldn't be surprised. This situation is often referred to as whack-a-mole, where every time you fix a bug, you run the risk of creating a bug somewhere else because of some interaction that you didn't know about or didn't fully understand. It's named after the old arcade game with the targets that pop up that you try to hit with a hammer. I talk about whack-a-mole a lot, and I've seen it kill a bunch of projects. And I even had a section on it in the mobile app development book I wrote more than 10 years ago. This isn't a plug, by the way, although it is FAQ. The book is called App Accomplished. It's permanently out of print, if for no other reason than because mobile development isn't a hot topic anymore. So one way that we as professional programmers deal with this is to try to limit the number of things that can interact with each other. Imagine how that same 100,000 line project, but now it's partitioned into well-designed modules with mostly private variables and a small number of well-defined public methods. Now you only have to worry about what's in the module you're actually changing and then double-checking some interactions between the module you change and others that touch the public methods that it calls. Still requires work, but it's so much easier than the everything is global case. But that's not really an option for neural networks. And knowing the problems that hundreds of global variables cause, much less trillions, my professional experience would lead me to expect this to cause a problem. And lo and behold, there turns out to be a problem called negative transfer that happens when the training that you're doing now has an adverse effect on training you did previously on an unrelated task. And when you try to retrain to fix the thing that just broke, you run the risk of a negative transfer breaking something else in the network. And that's pretty much the same symptoms as whack-a-mole. So my educated guess is that this negative transfer problem is the equivalent of the standard software engineering problem that leads to what's called whack-a-mole. And the two things are connected. And it sounds like this is a training problem, and it is. And that sounds bad, and it is. But it's probably even worse than it sounds. And not just because it can lead to the problem called catastrophic forgetting, which is not a good thing, although that happens too. There's a thing that defines human intelligence that the AI companies just haven't cracked yet, and that's learning. Humans have a very complicated system of short-term memory that gets saved into long-term memory as we sleep, or at least we're pretty sure that sleep is involved. There's a lot about how that works that we still don't completely understand. The current crop of AIs are all frozen in time at the end of their training. I've made a video likening it to the character from the Memento movie, and I've also heard it compared to the character in a movie called 50 First Dates, although I've never seen that one. The AI companies seem to mostly avoid discussing this topic, but I think it's important. In fact, I'm going to go out on a limb here and say that one of the requirements for artificial general intelligence is not to be as brain damaged as the Memento guy, but feel free to disagree in the comments. It seems to me that having some kind of working long-term memory is a minimum requirement for anything claiming human-like intelligence, much less superintelligence. And that makes this problem, whether you call it a global variable or whack-a-mole or weight of transfer or catastrophic forgetting or whatever, to be something that I expect will have to be solved before the AI companies' ambitions can be realized. And I haven't seen any real advancements on that front from any of the AI companies or much of the research. Few AIs that have been released have any kind of learning mechanisms, and a lot of those have had to be quickly shut down after they learned the wrong thing. Here's what I mean when I say these AIs are just software. The situations that cause things to go wrong in business software or web software also cause things to go wrong with these AIs. It might not sound like the same kind of problem, but only because the industry goes to great lengths to use vocabulary associated with brains instead of with computers. But they're the same problems because it's the same mechanisms. Software is software is software, even if they try to call it something else. This is one of the reasons that I've never believed the AI hype, because I've learned over the decades and many sleepless nights that software is complicated and there are so many ways that software can go wrong. And getting it right is not as easy as the AI companies are trying to make it seem. And if you are one of the people that watch this channel because you are or want to be a part of the software industry, I hope that helps you see reasons that your skills are more relevant in the current era than AI companies would like you or the rest of the world to believe. Because despite what the companies want you to believe, the skills that you've developed to understand software still apply in the AI and machine learning space. There's some extra stuff you're going to need to learn too, but it's not a whole different science the way the AI industry wants you to believe that they are. Thanks for watching. Let's be careful out there.